right, we're going to go ahead and get started. So welcome everybody. I'm very glad you all could be here. My name is Rose Sobel, and we've got Dan Barbersek, who I'll introduce with more detail in just a moment, but we're very glad y'all are all here. And looks like we're going to avoid any weather this morning, and that'll come later after the workshop, and hopefully no one will need their generator in the next couple days, but just in case, hopefully we help you feel prepared for that. I've got a couple of general information announcements, and then we'll get started. So we're going to start with a couple of breaks. So we're going to talk first about overview of generator maintenance, reliability for the first hour, hour and a half, and we'll have a couple minutes break. Then we'll come back and talk about generator safety from about 10:30 to 11. We'll have another little break, and then we will go outside for the last portion when it's nice and hot out. And we've got, thank you to the city of Corpus Christi, who's got a generator that they're bringing up that we can look at and get into some more specific questions. And Dan's got some demonstrations he's going to do. And then we will wrap up. We'll come back inside. We need everyone to fill in the survey so we can hear what your feedback was, what you liked about the event, what you didn't like about the workshop. So in order to get your CEUs, you do have to give us that survey. So when we're outside at the generator, don't leave, come back inside and fill in that survey before you go. And along those lines as well, if you didn't put in your water operator license number, please add that in so you can get your CEUs. If you're not sure what it is, we can help you look it up. I think a lot of folks filled it in ahead of time, but just in case, just make sure by your name that you've got your license number. I think that's all of our kind of general housekeeping. I wanted to get a little bit of a show of hands. Who has generators already in place at their water system? Who's still waiting and trying to order some generators? All right, and then what kind of size generators are folks working with? You can just call them out. In terms of kilowatts. 250s.
Are they all diesel?
Yes.
Yeah. Any natural gas? No. Okay.
All right, good to know. And then, all right, what are some questions that y'all have, or what are some things you're hoping to get out of this workshop? Because Dan can answer any and all the questions you might have, but we want to make sure you're getting some value from this. So what are some of the questions that you have or things that you're hoping to get from this workshop today?
Like a maintenance plan? Maintenance plan.
That's great. Yeah, that's super critical.
I guess it'd be similar for us. The ones we're getting are going to be about three times the size of the Connex that's out there, like big ones. And they said we're going to run them once a week and then load test them once a month. And we haven't had them before. Some of them are in place, some of them are not in place yet. But they haven't passed to us yet, so we're not taking them over yet. And so that some of that information might come with them once they're ready to turn them over. But we thought we'd get a jump start on that, kind of get familiarized with how to take care of that kind of stuff.
Great.
Who has mobile generators? Does anyone have mobile generators in their fleets? Okay. Yeah. Okay.
As well. Perfect. Yeah, so we'll want to distinguish between some of the different maintenance activities between mobile or permanent. Any other questions, things that y'all want to get out of this workshop? All right, well, please feel free when Dan is talking to raise your hand to ask questions, to get more information on any of the topics that he talks about. I'm going to go ahead and introduce our speaker, and then we'll get right into it. So we have today Dan Barbersek. He is the Director of Business Development and Power Generation for Waukesha Pierce Industries. He develops all aspects of power generation from emergency standby to continuous power applications. And prior to this role, he was the Senior Director of Power Generation, managing everything from parts to sales to service. And before that, he was Director of Energy Management with responsibilities for non-emergency generator applications, and was the Director of Power Solutions and Industrial Sales. He started his career at Generac as a Power Solutions Manager, supporting channel distributions with engineering support, with a special focus on the healthcare market. He brings over 40 years of energy industry experience, encompassing distributed generation projects, digital paralleling switchgear, as well as traditional paralleling concept. He's worked with power generation manufacturers as well, and as a product rep at the U.S. Navy. In addition, Dan is experienced in both rotary and static UPS technologies and has a great focus on all aspects of critical power applications. And he currently serves as the chair of the board of directors for EGSA. So thanks very much, Dan.
Thank you.
We'll get started.
Thank you. It's a lot. All that says is I'm old. That's all that says. So it's a pleasure to be here. Before we get started, I'll just talk a little bit about Waukesha Pierce. So that's presently who I work with. We are a Texas family-owned company. So we just turned 100 years old this last April. So we're in our 4th generation of leadership. So Lewis Pierce IV is the new man taking over the helm. So we are the Generac industrial distributor for the entire state of Texas. We are the Waukesha engine distributor for North America. So we've got offices throughout North America, some in Canada, some in Alaska. And if you're not familiar with the Waukesha engine, it's a large natural gas engine that's used for continuous duty. So what we use it for the most is in the gas compression, oil and gas fields. So it's running all the time. We're known for going out there, swinging the engine out, putting a new one in, bring it back to our shop, tear it down to the core, zero the meter out, and send it back out again. We also put alternators on the back end of those engines, and then we do prime power applications. So what's unique about the Waukesha engine is it can eat bad gas. So we're doing a lot of flare gas stuff. So the crypto, Bitcoin, I'm sorry, I don't even understand it, but they're out there. And so they come and they bring their servers out there, and we run on flare gas, and we power up their servers out in the oil fields. So as well, along with that as well, we are the Komatsu distributor for eastern part of Texas. And also, we just bought the distributorship for Louisiana, and so that puts us in Louisiana and Arkansas. So fairly good size organization. So just kind of went over the agenda. So let me just start off with this. So when you hear the word maintenance, like what's your thought when you hear maintenance? Like, what does that word mean to you?
Changing oil, belts, preventing breakdowns.
Right, work, right? Got a schedule, got some work to do. I'm going to be doing some maintenance, right? For me, in my world, maintenance means reliability. That's what maintenance really is. It's reliability. So if you don't do the maintenance, it's not going to be there when you need it. You know, the analogy I always like to give, and this is one of my favorite ones, is I'm a hockey guy, I'm a football guy, I like to watch my TV, right? So I'm there on Sunday and I'm watching the game on the couch. You know, maybe I got Dos Equis there or not. And the wife comes in and goes, mow the yard now. And I got to get up and I got to run, I got to start the mower and I got to run up and down the yard. That's kind of what you're asking of a standby generator too. It sits there all the time, but when you need it, it's got to be there, and it's got to be there usually within 10 seconds. So it's a lot to ask. So if you're not on top of this piece of equipment, it's not going to perform the way you want it to perform. So the way I'm going to start off this course today is kind of break down the reliability aspects of a generator. I know people are talking about maintenance schedules and things like that. We will definitely cover that, but I want to break this down to show you what it takes to make a generator reliable. So we give this presentation a lot to the engineering community. So as we're talking consulting engineers, we're saying, hey, this is some of the things you need to be looking at and thinking about as you're designing and selecting people for your projects. So the Nuclear Regulatory Commission did a big study on generators out in the field. And one of the biggest things that they came up with were things to watch for is water and corrosion. Water and corrosion are really the couple of the biggest worries that you have when you're operating a gen set in a standby application. So they break it down basically in these elements right here: design, testing, operation, and maintenance. Those are basically your ladders of reliability when it comes to operating standby generators. And this is from their study. There's been more studies since then. There's a big one that was done with the Army Corps of Engineers and MIT as well on generator reliability, as well as the robustness of our natural gas distribution system in North America. So that's pretty interesting survey that they came out with on that one. So nines, you hear the reliability, 9 nines, the more nines you have, all it takes is one issue in that whole reliability chain to make this generator not reliable. Does anyone want to take a guess what the number one failure is of a generator? Batteries. That's my answer. Everyone else wants to blame y'all. Everyone says operator error is the first one. But in my world, it's batteries. Batteries are the number one failure of a generator. Anyone know what number two is? Fuel. Look at this. Nice. Fuel is number two. So here's the reliability chain that we were talking about. And who's got what responsibility, right? So you've got the design. And that's a big deal. That part's a big deal. Do you have the right generator in the right application doing the right job? There's a lot to that comment right there. What kind of loads is this thing powering? Is it powering big motors? Is it powering sub pumps? What does this generator need to carry? So having that design correct is a huge deal in the beginning of it. And that's why we spend most of our time with the engineering community. Because what will happen is they'll put the wrong one in, and then it's not working right, and who gets the finger pointed at them? The guy's there with the shirt that matches the generator, right? Because the engineer, he's not there. He's not there. So we spend a lot of time at that part. The product design and product manufacturing, that's mainly when we talk to the engineers about that. That really doesn't come to your level, but choosing the right manufacturers out there. And I'll say this, this is a very mature market segment, right? Generators have been around for a long time at this point. So it's the big boys that are left. You got CAT, you got Cummins, you got Kohler, you got Generac, you got MTU. These are the guys that are here. So there's no more of these stories, oh, they bought that generator, they're going to learn their lesson. That stuff has kind of gone away. Everyone kind of knows what they're doing. I mean, all those companies I just mentioned are well over 50 years old at this point. Now, the one thing I will tell you, and this is somewhat of a new thing, is we just went through 3 years of supply chain issues. You guys are still feeling that. I saw raise of hands, people waiting for product, right? So what that means is some other people got into the business. Some other people got into the market. So there are people coming in from Turkey. That company's called ASCA. There's people coming in from China. And there's people coming in from Italy. There's people coming in from the UK. So people have got their way in here because of the supply chain problems. So engineers that would have held them off, said, hey, we need product, and they let them in. Now, for the most part, the main components are pretty commonly used. They use a Perkins engine and a Leroy Summer alternator, whoever. But the issues that people are running into is that there's no support for it, right? So when it breaks, there's no one available to come. And for your guys' world, you guys do a lot of bidding. You guys get a lot of low bids out there, right? And I'm sure you've felt that in the past. So some of these guys got their way in, and it's been a problem. We've been cleaning some of it up. So just something to kind of keep a little bit more aware of. Is the generator installed correctly? Another big thing that will continue to bite you. If it's not installed right, it's usually something that doesn't pop up right away. It could be not grounded properly. It could be fuel systems not right. So there could be things that will creep up after the fact, and once you troubleshoot it, it goes back to how the generator was installed. And then, of course, training on you guys. Whether you guys are doing your own or whether you do third party. How many people here do their own maintenance on the gens? Not many. Everyone contracts it out? Okay. That's another thing to be aware of as well. So I can tell you, I've been around in the business for a while. What generally we see happen is we're a big company. We've got big trucks. We've got lots of parts on our trucks, right? So we have a burden rate. It's expensive for me to roll my truck down the highway. So our contracts can be a little bit higher than most. We're at the same level of the major players. But then we start competing against a guy in a pickup truck with the oil drum in the back, and they come in low. And so everyone goes, oh, wow, I've saved a bunch of money. The person that made that decision, they got promoted, they move on, and everyone's happy. And what happens with the standby market is a lot of times it won't get exposed that the work's not being done. Because if you don't have an outage in a while, you don't know, right? Then the outage comes and everyone goes, holy crap, this isn't working right. We're in the dark and now we've experienced an outage. And then people come back behind them and go, oh my gosh, you got the same filters, you got the same everything, nothing's been touched. So we see this cycle, it lasts for about 2 years, and then all of a sudden they come back and then we fix everything and we charge them to fix everything. So the money they saved went away because we had to do all this extra work, and then we go through this cycle. So that's another thing when it comes to going with outside people. Just make sure you know who you're dealing with. There's a lot of good companies out there doing good work, but if some guy's coming in super low, be cautious. Okay, talking about the role of the engineering community, sizing is a big thing. The hardest load that a generator has to see is a motor load. That's the hardest load that a generator will see. Elevators, for you guys, big pumps, powering maybe a soft starter on the front end of it. And so let's just talk about powering up a motor real quick. So the way a motor works is you've got your windings in your stator, right? And so you put electricity to those windings and it makes an electromagnetic field. And so by doing that, it causes the rotor to turn, just like you do with two magnets, right? They start opposing each other. And that's what gets your spin, okay? So you're exciting the windings, you're making the field gets made, the rotor starts to spin, and what you have is when the generator first sees that energizing of those windings, it thinks it's a dead short because nothing's happening, right? You got all this power flow at once and it's going, whoa, what just happened? I need to put a lot more power into this to get it spinning. Now you guys are even harder because you guys have what we call impellers on the end of your motors, right? So now we've got wellhead pressure to deal with as well. So we've got the motor and we've got the impeller with water column on it. So these are the discussions that we have with the consulting engineer. So when he's looking at your load profiles, what we're doing is trying to get that generator zeroed in. And the tricky part here, and we'll go into this a lot more later on in this course, is I need the generator sized right. You are not doing me any favors by buying too much generator. The generator is designed to run with load on it. So if you don't have enough load on it, it's not going to operate the way it's supposed to operate, right? So it's that tricky business of not overbuying, but zeroing in on the right product. Now, the other thing that you guys have are submersible pumps. And so the difference between a submersible pump is that the windings are now long. You guys seen those submersible motors, right? So you've got long windings going down this motor casing. And so the problem that we have with that is because you've stretched the windings out, it's harder for us to make a good electromagnetic field around it. So submersible pumps are things that we pause. We want to know about it, and we want to know about the water column above it, right? So just kind of give you a little engineering behind why those are tricky for us. Supporting systems, fuel, air, we'll get into that a little bit more. Location of equipment is a big deal. Location of equipment is a big deal. You need to know where you're putting this generator. One, for servicing, of course. Can we get to it, easily and do what we need to do in a timely manner? But also for reliability. So a few years back, had that big tornado in Joplin, Missouri, and that one really made the news because it was so destructive, but it hit a hospital there, right? An F5 tornado direct hit on the main hospital, which was just so many stories in itself, because during a disaster, most people flood to hospitals. Hospitals become a beacon. And when they got there, of course, there's nothing left. The issue that they had at that place was that they put the generator plant on the west side of the hospital, directly in the path of where the wind comes from. So the first thing to go was their backup power. So where you place that generator is important. Knowing where your winds are coming from, knowing which way the weather comes from, knowing if you're in a flood area. You know, that was another thing that we ran into, a big hurricane there in Mississippi, and I'm sorry, I run out of remember which hurricanes they were. But there was a big one that hit Baton Rouge, so we'd gone down there, and big time failures everywhere. There's a lot of post-analysis after all these things, right? So they go, okay, well, all of our generators flooded. So now they came up with a new rule. I think 75 miles from the coast, every single generator's got to be on a 12-foot platform. Like, okay, that's great. So I went down there and thanked them all, because you're going to save my generator, but you're not going to run because all your distribution is still at ground level. So until you bring up all your services and all your distribution, this 12-foot platform is not going to do you anything, right? But people try to learn from these. And we're going to talk a lot about code today too. And code is not to be a pain in your neck. Code is they've learned a lesson. They've learned a lesson, and they're trying to teach people the lesson through code. But a lot of times when they do code, they don't really think it all the way through on the impact that code can have, right? It's like EV cars. Let's all do EV cars. Well, there's not enough batteries, not enough charging stations. So that's another thing to consider as well. And then code, we talk a lot about with our installing contractor. Codes can change, everyone. The National Electric Code, the NEC, that is just a basis. Any county can build upon their code the way they deem. So they can up their electrical requirements, they can up their fuel issues, they can up their sound. It's up to them where they bring it. So the NEC and the other codes are the base level of codes. So we help a lot of people with that. I know if I'm going to put a generator in Dallas, you're going to need a 2085 tank. If you want one in Plano, you're going to need everything, because they hate generators in Plano. But you got to know that, because the guy will show up and he won't sign off on your system, and you'll be standing there and trying to fix it after it's installed is costly. Selecting the OEM, you know, are they in this business? Is this what they do? Is this their core business? Like I said, this is more with talking to the engineers about selecting them. Of course, we're a Generac distributor. They've got 100,000 square, or no, a million square feet of manufacturing in the U.S. right now. So Generac is the second largest generator manufacturer in North America, and the #1 natural gas generator in the world right now. So they've grown up. And the dealer's role. The dealer's role. What is the dealer's responsibility? The guy that you bought the generator from. Of course, they're the ones that are going to come out and do the commissioning and make sure that the unit's all within specs and it's been installed properly. Then they're going to be the ones that are going to register that unit for warranty to make sure that, you know, you get what you paid for. End user training. That's a really tricky one too. A lot of people want it. A lot of water people want this as well. The problem that we have with that is that generally when we're there for startup, no one else is there, right? The contractor's just finishing up. We commission the generator, maybe the HJ there, the fire marshal's there, right? But you guys aren't there yet. The people that need to know the operation of the generator aren't on site yet. So a lot of times we'll talk to people. We find this piece to be very important, but I don't want to put that money in at the front end, because a lot of times it will make us uncompetitive, and then no one gets the training. So I think it's a very important piece that needs to be discussed, but it's hard to do it during the commissioning time. End user's role, of course, having basic understanding of the operation, and the other one is managing your growth. And you guys, all y'all, are horrible when it comes to this part, right? Because what happens is you guys start growing or you start changing the equipment around. So now you start, oh, let's put this on the generator. Let's put that on the generator. Oh, let's tie in over here because it's nice and close. So managing how you're going to grow your system is a big deal, and we'll get more into that in the presentation. Monthly load testing, I heard that, weekly load testing. We recommend that it's weekly. I'll get more into this into the presentation, but running that generator is really important. And to me, personally, and I started off as a military guy, I started off as a field service technician. To me, running a generator without load on it is a waste of everybody's time and fuel. Because the only thing you're testing are the start batteries. You're not rolling the building, you're not putting any load on it. It's just the start batteries. And all you're proving is that at that point, those batteries were good. That could not be the same conversation a week later, right? So putting load onto a generator is really important. And we'll go more and more into why that is. It's to the point that NFPA, the National Fire Protection Association, they actually have it specifically spelled out on what test is required when it comes to healthcare. So they want monthly, they want weekly, they want with load. If you don't have enough building load at your facility, then they want you to bring in a load bank at the end of the year. So they've spelled it out. So the reliability of a generator is that whole chain. And that's just the chain of events to get the generator to your site. So now we'll talk about a little bit about what it takes on the actual generator itself. So this is an easy way to kind of get your head around it. So generators basically, an engine generator basically is a series of subsystems, right? So basically you've got an engine, you've got an alternator or a generator on the back end of it, and you got controls, right? So it's those three pieces together is what's making the gen set operate, right? So if you look at that all as a subsystem, kind of gives you an idea when it comes to reliability. So let's say you've got an engine issue and you're down, but you're down at this point, you're down for that long, that's fine, you're just down because of that one subsystem. But if you get a subsystem failure once a year on a different subsystem, then your overall reliability is going to be affected, right? You're not feeling it during that time, but you'll feel it at the end of the year, right? Because if you lose your control system, the generator's not going to work. So paying attention to each one of these subsystems is the key to reliability when it comes to the genset. So another way to get around that is paralleling the generators together. So if you get one generator's down because of a subsystem or two subsystems, whatever, one generator's down, you've got another generator there to back it up. So there's two reasons to parallel engine generators together. One is for redundancy. So the generator size, let's say you've got a 500, got two 500s there, right? So that customer's load is 500 kW or less. So they're both running at the same time. They split that load up, they share it, but in the event one of the generators was to have a problem, the other generator is there, and no harm, no foul, right? Data centers, hospitals, airports, these are the people that are paralleling generators. The other reason to parallel generators together is for capacity. So let's say I need 1 megawatt, but I don't have it, so I can put more generators together to make the 1 megawatt. Generally, what we see when you parallel generators is generally you're paralleling for redundancy, is what we see. Has anyone worked with paralleling generators before? No? And that doesn't surprise me, even when I talk to the engineering community. And the reason for that is the technology for paralleling engine generators for a long time was cumbersome, right? You had a piece of switchgear there, right? You've got a big electrically operated breaker. You've got a control cabinet up in the front. And you've got all the controls to control the generator, and you use this breaker to tie the generators together, right? That section alone, $80,000. Okay, so now you're going to do 2 generators. You're at $160,000 right now. Now you need the overall control system, so that's another $50,000. So you're in $200,000 to parallel 2 engine generators together. So a lot of people said, hey, you can't parallel small gens together. It's like, no, wait, you can. It's just not economical to do that. So because of the technology available for such a long time, what this did was this pushed generator paralleling to the elite, to the big data center guys, to the big hospital guys, the guys that had those capital budgets, right? Because of the cost that it took to get those 2 gens together. The benefits are just fantastic, right? Just benefits are all over the place, but it's hard to get across that capital cost. And the footprint, where are you going to put this gear? You know, where are you going to put it? So I can tell you today, that's all changed. That's all gone away. So now they put the controls of paralleling generators on the generator. They can put a paralleling switch on the generator. And so now you can plug a control wire between the 2 of them so they talk to each other and they self-parallel. So that's where it's got to today. So now I'm seeing parallel generators where I would never thought I would see it before. Doctors' offices, because they're doing some kind of a procedure inside the building, right? I used to live in North Carolina. We had parallel generators at a church. You know, we went to the church service and we got done. We all held hands and went out back. I showed them how to parallel the generators, right? So it's really opening the market for paralleling generators. And you can do it at a good cost for it as well. So that world's changing quite a bit. So this was an example. This was actually a big data center. This happens to be in Canada. When it started off, there was 1 generator on each pad. So as that customer grew and they brought more and more loads in, they just dropped another generator. But of course, you had to have the system designed to be able to handle that ampacity of growth, right? You can't do it after the fact. You've got to have enough wire and distribution to handle the additional growth that you're going to bring on. But the benefit to this is that right out of the gate, they didn't overspend, or they didn't buy a huge generator that was going to be lightly loaded for a long time. We just finished the courthouse. So we've got 4 natural gas generators here in Corpus that you can tie up to the utility grid. And we just did the jail not too long ago as well. And I think there's 2 500s out there that are paralleled. So if you want to see parallel generators, they're some right up the road. So strong maintenance testing. Visual checks are good. We'll talk a little bit about people used to put generators in the building, but now that's kind of gone away. Testing. I talked about NFPA 110. If you're just curious about that, just go ahead and look that up, and it gives you the guide of what they want you to do to test your generator, how much load you should put on it, and how many times. Okay, the alternator. Just like an engine, the alternator gets warm, right? Whenever you're making electricity and you've got load on it, you're going to create some heat. So the alternator's got fins on it. So when it's spinning, it's sucking air across the windings. The reason I bring this up is that people tend to stack things near generators. And please don't stack things near generators, okay? They have to breathe. It's not just about the exhaust of the radiator. You've got to get airflow across that alternator quickly. Now, most generators today in everyday applications don't have protection on heat on the windings. Some of your more complicated jobs, they'll put what they refer to as click-ons embedded into the windings. So if the windings get too hot, they will stop excitation. But for the most part, most generators don't have that. So you'll melt the windings and the generator won't know until it fails. Which is kind of a military thing too. I mean, Chicago does this. You know, they had one little fire in Chicago, you know. But Chicago, any generator that goes into Chicago, all safeties have to be turned off. They don't believe in low oil. They don't believe in over temp. They call what we call battle mode. So that means you run until you die. I do too. I'm an ex-military guy. That's how we operate our generators. You run them till either power comes back up or you get your system back going or whatever the case is. But your job is to do that until you can't. People are a lot nicer to them now. So a little bit of a technical drawing here. And the reason I want to bring this up is basically just tell you how the windings are wound inside of an alternator and why this is kind of important to you guys. So the one on my far right, that's a Y winding. That's typically what you're going to see. You're going to see a 4-wire system, right? A phase, B phase, C phase, neutral in the ground. The other is a demonstration of a delta system. You don't see a lot of deltas anymore. It's mainly an industrial application. They don't need the neutral there. They're trying to save money in copper, but generally you don't see that very often. So why I'm bringing this up to you is basically it's a series of windings that are in this alternator, and how we connect those windings together determine how much voltage we give on the output. Okay, so how they're connected internally changes your output voltage. But what you basically have here is you've got a series of different windings that are for each different phase. So this could be A phase, this could be B phase, that could be C phase, right? When I talked about you guys shifting your loads around, so if you go to a generator and you look at it and one phase has got 90% of the load and one's got 50 and one's got 10, you are stressing out those windings internally. It's the combination of these windings what gives you your output, not one phase of it, right? If you got a 100 kW generator, you can't get 100 kW on each phase, okay? So as you're moving loads around, because it's convenient, because I could get to it here and not have to run wire to go over there, the backlash of that is that you're stressing the windings internally into the alternator. And one day it fails, and no one knows why, right? Because it just blew up, and now you're replacing it, and everyone's like, it ran good here for 5 years, I don't know what happened, and no one's troubleshooting it because it blew up and it worked before, and now you put a new one in, now you put it back in the same situation again. Maybe it goes another 4 years, maybe it goes another 5, I don't know. But balancing those loads out has a big impact on that genset. Breakers, huge problem. Huge, huge, huge problem. People go out there and they do lockout, tagout, and they don't do reclose. They'll go out there, they'll open up the genset breaker, they'll do what they have to do, and they forget to close it. In my company, you can do that one time. You do it twice and you're fired. Okay? It's a big problem. So most of these breakers have got little auxiliary contacts on it. If you have a way just to monitor the position of that breaker, that'd be fantastic, right? Know if that breaker is open or if that breaker is closed. Now, most of these breakers have got either electronic trips built into it. For you guys in the water, it's mainly thermal trips. So it's more of a heat thing. It's like it's a bimetal strip that gets in there. So too much current heats it up and it warps the metal, and that by warping it, it trips the breaker, right? So that's called a thermal trip, right? There are electronic tripped breakers as well. So you put a voltage to it and it trips the breaker. So the application for that would be, a lot of times people will do it on fire suppression. So there's a fire in the building, and there's different philosophies with this, right? Sometimes there's a fire in the building, they want to secure all power in the building. Fire alarm goes off, it trips the breaker. Now, other people go, no, don't trip the breaker in the generator. I want to keep power on so we can do whatever. We can do smoke evacuation, we can do whatever may be. So you have that conversation in the beginning going, what do you want the generator to do in those kinds of events? Now, there also will be way for the firemen to secure all power going into that building. So they want to know where a generator is. You have to have the right name tag on your building so they know there's a generator on the site so they can secure the power prior to going in to fight the fire. Now, another reason to have electronic trip is they make what they call a closed transition transfer switch. That's what this is, CTTS, or an overlap transfer switch. So basically, a generator transfer switch sits out there and it monitors the utility's condition, right? So it's from there you set your exercise time, you set all that from in that switch. So that switch goes, okay, I'm watching the utility. Utility is now without a specification. It's out of specification for whatever, how long you set it to be out of spec for. And then the generator or the ATS will tell the generator to start, right? So let's say the utility goes out, the switch sees it, it tells the generator to start, generator starts up, then the switch goes, oh, I see generator voltage here. It's within specification, so I'm going to transfer my switch onto the generator. And now you're powering the building, okay? So now utility comes back. So utility comes back and the transfer switch goes, oh, utility's back. And it's back for however long you set it for. Generally 15, 30 minutes. We want to make sure the utility is going to stay back. If you've ever noticed the utility will come back sometimes and then goes out right away, they're doing reclosures, is what that's called. What they're trying to do is they're trying to blow things off the line, right? So they'll close it just to send a jolt down the line to clear a limb or whatever the case may be. Or they're just switching to different grids, okay, trying to get power back to you. So you don't want your building exposed to all that jumping around stuff, right? So that's when we say, hey, stay there for 15 minutes, 30 minutes, then you know the utility is going to stay there. So the transfer switch goes, okay, you're good. So let's say you have your timer set for 15 minutes. 14 minutes and 33 seconds into it, it goes out of spec. It goes back to 15 again. So a lot of times we'll get a call going, hey, utility's been back, but the generator hasn't transferred back yet. Like, well, has it been there reliably for the amount of time? So when it transfers back, what does it do? It breaks from the generator and goes to the utility. So what that causes is another outage in your building, right? So every event, you will lose power twice. The first time, because the event happened, and the second time when you're transferring back to utility. If you have a closed transition transfer switch, you avoid that second hit. So what that switch can do is that switch goes, okay, utility's back. I'm going to wait till the generator and the utility align with each other. And once they've aligned with each other, I'm going to close on top of it and then let go. So that way there's no interruption coming back. So you have to ask the utility company if you're allowed to do this in your area. Most utility companies, they say yes, they say no. But they do say that if you are going to do that, you cannot be tied to me longer than 100 milliseconds. So once you're on, tick-tock, you've got 100 milliseconds to go. If you don't break away in 100 milliseconds, that transfer switch will shunt trip the generator breaker and force it off. So that's the other application. But it's definitely utility driven. So where's the application for this? Hospitals, major data centers, most every single airport, right? NASDAQ stock market was a good example. I used to support them back in the day. They used to have 3 big screens up there, right? They had the Weather Channel, they had the Dow Jones stock market thing ticker up there, and they had the cartoon channel up there, right? But they would watch for storms. They would watch for a storm. And if a storm was coming their way, they would make the decision to go on to generators. So by them making that decision, you've walked your load over with no interruption at all. And now you just hunker down and let the storm go past you. Because that's generally when things start breaking, right? The utility starts getting weird, different voltages are happening, it's single phasing, whatever, and it could just come in and punch your facility right in the face, right? So this way they just stay off of it, let it ride out, and then come back. So I like them. I like those switches. Do any of you guys, have you ever seen the closed transition switch? Yeah. You have them? Yeah. Okay, let's talk about fuel. So diesel engine, compression, ignition. Everyone understands that, right? Compression, ignition. So what this block is doing is it's squeezing diesel fuel to the point that it gets hot, to the point that the fuel explodes. So by compressing it is what's causing the explosion in the cylinder. Now these are famous for generators having diesel, especially for portable generators, because you can bring fuel with it. You get a lot of power out of that block because the way that you compress, you get more power in your strokes. So a very, very common approach is a diesel generator. Now we'll talk more about natural gas coming up because that's changing in the landscape as we speak. So the other thing you have out there, if you notice under here, is a biofuel generator. So a biofuel is not that common. It's not that common in the market. It's been around since Ferdinand Diesel first invented a diesel engine, but it's just not that common. So let's talk about this technology. Don't get this confused with dual fuel. So dual fuel generators can run on natural gas, right? And in the event natural gas goes away, it will automatically switch over to propane. So that's one fuel or the other. That's a dual fuel. Now, the challenge that you have with propane is propane gives off a lot of BTUs. So propane is hot. And so to combat the heat, you got to put a lot of block there. And what happens is, as you start getting bigger, the cost of the block pushes the generator pricing out of the market, right? So about 150 kW is generally where you stop with propane. Just because you go any larger, the block becomes so big, it's so expensive, and you got yourself a 200 kW, and you've paid way too much money for it. We see a lot of these, the dual fuels at like fire stations and police stations. They really like to have the ease of having natural gas, but also have stored fuel on site. But what we have up here is a biofuel. So what a biofuel is a biofuel is a diesel engine, okay? So it's a compression engine, so that means no spark plugs, right? So no diesel fuel, and it doesn't work. So the way it works is there's an outage, it starts up, it's eating diesel fuel, it's starting to bring on load, the block's starting to get hotter, you're starting to get larger explosions in your cylinders. So then at a certain load point, the determination is made on the control system to allow natural gas to start coming into the air intake. So natural gas is now going to come in pre-turbo. So your turbo mixes your natural gas with your air and brings that into the block. So what that does is now you're getting better ignition in your system like you do with your car on a cold day. If you notice on a cold day, you can get more horsepower out of your vehicles because there's more oxygen per square foot. So now we brought natural gas in. So the governor doesn't know what's going on. The governor goes, okay, I need this much fuel to maintain 1800 RPM. Now we start bringing natural gas in. Now it goes, oh, I need less, I need less, I need less, I need. Now I only need this much fuel to do 1800 RPM. So it starts to naturally back off using your diesel. Now you can't thin it out too much because diesel's got several other different roles in the engine. One, it's a lubricant. Okay, so it's designed to be a lubricant as well. It's also designed to help cool that block as well. So you can't lower it down too much, right? So you bring it down, and now you're running more on natural gas than you are on diesel. So the diesel fuel changed roles. It changed roles from being the prime mover of pushing your piston down to now, by it exploding, it's acting like a chemical spark to ignite the natural gas. So it takes the place of a spark plug. So, layman's terms, a biofuel engine, you put a 24-hour sub-base tank on it, it's now going to run for 4 days instead of for 1. It's cool. I like it. You get a big load step on it, it's going to see it. The engine's going to call for more diesel fuel. More diesel fuel is going to fill the need of the load step. It's going to back off the natural gas, let the diesel do its thing. Once it calms down again, the gas starts to come back in. So that's a biofuel. There's only a couple of manufacturers today that have them that are EPA certified. Okay, Generac's one of them. They've got only two nodes, a 500 and a 600 kW. Volvo does it by themselves in a 500 kW. And the reason they're doing it at that size is that because of the tier requirements of the smaller gensets, those fuel delivery systems are so sophisticated. If you start throwing them off with natural gas, they get lost. So they have to go to like somewhat of a dumber fuel delivery system to be able to operate better. So where do you see these? You see these in a couple different applications. One is where the customer just needs a long run time. They need a long run time and they don't want to have 20,000 gallons of diesel fuel at their site. So they'll do that. Other applications are where the landlord won't let you have that much fuel at your facility. So the landlord goes, you can only have this much, but their business model requires them to run longer. A biofuel will help them get to that billet. So been around for a while. I'm a fan. One of the problems we run into is they tend not to use up their diesel fuel, and that's a problem. So we say, hey, shut your gas off for a little bit so you can kind of run through your fuel. But that's an option that's out there. Spark ignited, of course, you got natural gas, you got LP vapor, LP liquid, and we talked about the dual fuel. So I kind of hit this a little bit. One of the things that the code says when you're doing emergency loads, the code says that your fuel must be reliable. Your fuel has to be reliable. That's all it says. Your fuel must be reliable. Okay. So a lot of people took that word or took that meaning as reliable means I own it. I have it. It's on site. It's mine. I own it. So it's reliable. I'm not waiting for someone to bring it to me like natural gas, right? So a lot of people took that meaning of being reliable. Well, what we've seen over the years is that natural gas has outperformed diesel. Natural gas has outperformed diesel delivery. Natural gas has been there, right? So we're seeing a lot more authorities having jurisdictions, AHJs or fire marshals, accepting natural gas to be a reliable fuel supply. Now, the only exception to that is the code states if you're a level 1 hospital, which means you have trauma, you've got operating, you must have on-site fuel. You have to have on-site fuel. So they got very specific on the level 1 hospital. So a biofuel is a good approach to that. So it's someone that can kind of get into the natural gas world and use the benefits of natural gas, but yet meet the code by having fuel at your facility. So natural gas, let's talk about this real quick. So until Uri came, I had a perfect story. Natural gas has never been secured during an event. Sandy, Katrina, Ike, natural gas always flowed. Even during Katrina. There was one town on Long Island that had a big fire, so they had to secure the gas there. I don't know if you remember, CNN would always stand in front of it whenever they did their reporting. But natural gas flowed. And there's a lot of lessons learned from that. So let's take Sandy. So Sandy was a big one. Of course, that was a northern storm, right? But the thing about Sandy was Sandy hit all the refineries. It hit all the refineries along the coast. Threw all the debris into the New York harbor, right? So the problem during Sandy was everyone ran out of fuel. Everyone ran out of fuel. No one could get fuel. You couldn't get tankers into the harbor because the Coast Guard has got to sweep the harbor, right? Because you want to bring a tanker in there after a hurricane, and you rupture your tanker in New York City, and you know. So that was that's a big lesson learned, right? When the freeze happened here in Texas, we lost some natural gas compression stations. So it's the first time that they ever secured natural gas during an event. But other than that, natural gas has always been there during these events. And so people are looking more and more at looking at natural gas just for the reliability aspect of it. We'll talk more about that when it comes with dealing with fuel. So we're seeing a big change. So our sales, like for us, I live in Houston. Our sales in Houston, we sell way more natural gas generators than we do diesel generators. Now, as we start getting out and distribution starts to get a little sparse, you won't see as many. But if the distribution is there, people are definitely going towards the natural gas, just because of the run times and perceived environmentally friendly. Okay, I think I kind of ran into this ahead of time on the biofuel. Just kind of give you some of these run times that you get out of it. Now, there are people that can put a kit on your unit after the fact without the OEM consent. My thing to that is to just be careful because when you have changed your fuel delivery system, you have affected your EPA listing. So a lot of them will come in and do it. The EPA doesn't have helicopters. You know, they don't fly over, but you have affected the EPA. Now, when you start running more on natural gas and less on diesel, so natural gas, your output is your particulate matter goes down, right? But because you're doing natural gas, your NOx goes up. So what Generac does is they put a catalyst in the exhaust of a biofuel to combat the NOx. But at the end of the day, the EPA considers them to be a diesel engine because if you don't have natural gas, you can run on diesel. Now, it can't be the other way around, right? No diesel fuel, you've lost everything. All right, let's talk a little bit about diesel fuel. This is generally what you'll see in the market today, right? A sub-base diesel fuel tank. So the generator will come, it's going to sit right on top of its own tank, it's going to pull from that tank, and you're good to go, all nice and enclosed. You've got breather vents, you've got overflow vents, you've got your level senders on here. That's generally what we see. Every now and then you'll see a bigger system where they may have a large diesel tank on site, so they may be running boilers and whatever, so they may opt to use that main tank to run the emergency generator. So generally what they'll do is they'll put what we refer to as a day tank near the gen. So the day tank would be 100, 200 gallons. So that tank will call for diesel fuel from the main tank, and then the generator will pull from that day tank. Tends to be a little bit more complicated, and we'll talk about that a little bit further, but this is typically what you see. Now they look square, or rectangle rather, they look rectangle to you, but if you look inside of it, it's actually beveled down to one corner. So the reason for that design is they want all the sediment and stuff to get down into the one corner away from the fuel intake. So it's beveled on the inside, right? Also, there's bevels in between, right? Because it's got to support the weight of the generator on top. But most of the OEMs, they'll come with this, they'll make it themselves, and they'll bring it here. They refer to these as a UL 142 tank. So this is a double wall tank. So that means if the inner wall breaches, the outer wall will contain the fuel, so you don't have a fuel spill. There are monitors in there to tell you if you got fuel in your outer wall, so you know that there's an issue. The last thing you want to do today is put a drop of diesel fuel in the ground. If you put a drop of diesel fuel in the ground, like you own all the ground around it, right? There's a lot to it to get past that. So they're very cautious about this. Lots of rules and regulations when it comes to diesel tanks, county by county, okay? Knoxville, Tennessee, you can't have a diesel tank within 100 feet of a well. Well, now you got to find all the wells, right? Dallas has got all kinds of emissions, different extender pipes. So there's lots of rules about diesel tanks, and they continue to drive more and more rules around this. But that's a reliable way to go. Keeps your fuel issue problems to a very minimum as far as getting fuel to the engine. Okay. So what makes diesel fuel go bad? Moisture. Water, right? Now, we just saw it, right? Okay. So how does water get in there? Look at you guys. You all read ahead. Condensation. Right? So think about it. They're all black. All the tanks are black, right? Because if they're white, they're going to look dirty, you know? So here we are in Texas. It's July. Nice black tank out there. Getting nice and fat. Just expanding, right? It's nice and big. Then it comes nighttime. Starts pulling that cool air into it. And it just sucks that moisture into the air vent. And it builds along the wall of the tank. And now you've got water in your tank. So, how do you get around that? Testing. Keep your tank full. Keeping your tank full will minimize that effect. But if you own fuel, you've got to monitor your fuel. The fuel manufacturers tell you 18 months. You better look at that fuel. 18 months. So when does 18 months start? Oh, does it?
The day it was made.
The day it's made. The day it's made. You think, oh, you're here, let's start the clock. That's right. That's right, it's not fresh diesel. There are federal regulations on the quality of fuel that can be delivered to your site. Okay? The federal government monitors that, right? They want to make sure that you're getting the quality like you do at your gas tank, right? You see that label on the side, tells you all what's in there, right? What's the first thing that they disregard during an event? They disregard that whole thing about your fuel. That goes away instantly. I've had people call me going, Dan, I think they're putting oil in my freaking tank. So it's a problem. It's a problem. Now you talked about testing and chemicals, and here's my thing. You need to have a fuel program. So you need to, at the very minimum, to have your fuel tested. And the idea here is you want to test it, and then if you have to, treat it before it's got too bad. Okay? I don't want to get morbid, but it's kind of like cancer. Once it gets to a point, there's no saving the patient. So you want to be ahead of it. You don't want to try to bring it back to life. You want to stay ahead of it and have a program. You want to have a company that does it that can filter it. And there's a lot to filtering a tank, okay? So I like to use the analogy of an aquarium. Anyone that's ever owned an aquarium. Aquarium is a good example. Your filter's running all the time and it's pretty as everything, right? Then you go in and you do this to the rocks and it's a mess, right? Same thing in the tank. You need to agitate the tank. You need to agitate it. One of the biggest failures, and we're going to talk more about this towards the end of the day today, when there's an event, anxiety is high. Anxiety is high when there's an event. So if you've got diesel tanks, have a relationship with a diesel supply guy. know who this person is and have some kind of a deal set up with this guy. Because I'll tell you what, he doesn't know who you are, okay? You may be important, right? You're water, you're important, you're infrastructure, but he doesn't know who you are. I used to have this conversation with my data center guys all the time because they've got big diesels and lots of fuel. They're like, well, I'm Chase Bank. I'm Chase Bank. He doesn't care. You know who he knows? He knows the guy down the road that's got boilers. Their trucks are there twice a week. They go hunting together. You know what I mean? He saw you 4 years ago. He didn't know your name. So you have to have that relationship. So let's say you're in an event, all right? You're in an event, you're starting to run out of fuel. Anxiety starts to increase. You call your guy. Your guy has got a special diesel delivery truck that can float across flooded roads. So that's awesome. So he gets to your site, climbs over trees, does the whole thing. He gets there, and what happens? He starts filling up your tank. Your on generator is filling it up. Then all of a sudden, bum, 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 bum. The engine just shut off. And he goes, not me. Not me. Now everyone comes running out, right? So what happened?
Turn up the debris in the tank.
That's right. Stirred up the debris in the tank. It's a prize day. Look at that. So think about it. You've got less volume of fuel in there, right? You've got less volume. And now you got all that debris on the bottom. There's nowhere for that debris to go. If you had a lot of fuel in there, maybe it wouldn't be as bad. But now it's exasperated because there's not much fuel there. So now what happens? So now I can tell you from experience, everybody is pissed. Everybody. My tech, the end user, the fuel guy, everyone is pissed. Because let's say he just drops the fuel filters, and by the luck of the Jesus, it's just those, right? He can drop them, he can bring new ones on, spin them up, and get you back online, right? But I can tell you, those generators have got a lot of suction. They have a lot of suction. They'll pull that right through that filter, put it right into your fuel rail, put it right at the ejector. And now this guy is out there tearing down your fuel rail in the field during an event. Not cool. So, when you're filling up your tank, you talk to everyone and say, we are going to shut the generator off. And we're going to top off our tank. So now what's the next question? Bless you. What's the next question after that? So we shut the generator off, we filled it up. What's the next question? Well, how long do I wait? Ooh, I had another koozie too. I had another one. How long do I wait?
45 minutes, 5 minutes.
Sure. Why not? I don't know. How well you've been taking care of your tank? I don't know.
Shine a flashlight in there.
Shine a flashlight. Get a clear plastic tube. Do that whole. Seriously, I don't know because I don't know what's been done to it. So having that program keeps you away from that. Keeps those sediments that they're going after them, right? Clean them out. It's just. They just change filters. They do a fat filter next, and they do a skinny one, and then they do a fine one, right? But they've got to agitate the tank, move it around, and run it through those filters. Okay?
Is there a drain plug usually in that spot you're saying that all the debris kind of collects in?
No. Liability. And the problem with agitating the tank is that you've got bevels in there. So there's holes for the fuel to get through, but if you got an agitator snake, do you know if you're getting through it or not? That's a challenge. I actually went to Generac and I worked for Generac for like 10 years. I'm like, can you give me the design of the tank so I know? Because now I'm a distributor and I really care. and I couldn't get it from them. But
Design issue.
yeah, and I got to tell you, so what took care of those organisms? What kept those organisms at bay was sulfur. So now they removed all the sulfur out, right? Because they emission friendly, low sulfur. That was the thing that was going after everything. Oh, great. Now you took the sulfur out. Now you've created it to happen even quicker. So it's a challenge, and you guys are here on the coast. Have you run into bad fuel? Do you know?
The winter storm.
Yeah. Yeah. We do a lot of the cell sites, so we got cell sites all over Texas. They get neglected, man, and who knows when they ran last. And we had one, they brought it to us, and it turned to like tar. We actually shipped it to some guy in Florida. He was doing some experiments in his basement. I'm like, what? We threw the tank away. Okay, threw the tank away. So it's a problem. There's got to be a maintenance. So here's the miss. Here's the miss that everyone does. You have this program. You got people coming out. They got their agitator snakes. They're doing all their thing, right? Now you need fuel delivery, and the guy pulls up and starts filling your tank up. And the next day you got a problem. Because why? You didn't check the quality of fuel he was giving you. When you have a fuel maintenance program, it goes all the way through. Okay? You take care of what you got, and you make sure you don't bring bad stuff in. So how you do that? Test it. You talk to the people. You tell them what your requirements are. I personally have seen a fleet of mobile generators for T-Mobile that got destroyed from one bad guy. Just filled it up with a bunch of junk. So have that. That's why we at WPI, we're careful about that stuff, about taking a fuel maintenance contract because of just that. So I could be doing your maintenance on your fuel all the time, and then one day you got a fuel problem because the guy gave you bad fuel. Who's going to get yelled at?
What would you recommend, and then highway diesel or off-road?
You can do off-road. You just have to know, you have to set the criteria of what he's going to deliver you, the quality of the fuel he's going to deliver you.
You can also get it on top of the truck and with a stick, and don't they have like a marker or something where you can just dip it in there and you pull the stick out and it gets a certain color?
Yeah, you could. My preference would not be a stick, would be a clear tube.
Yeah, well, like clear too.
Yeah, yeah, do the old straw trick to it, right? And pull it up. Yeah, yep.
Get a sample.
But you gotta, our sample things are that. So we got sticks with tubes on them and we pull out from the bottom. Yep. But you can't play. And the more fuel you have, the more of a problem it is. So I keep mentioning these data center guys, right? So Google is a good example. So where I lived in North Carolina, Google had a data center up the road next town from us. They had 22 megawatt gensets there. 22 megawatts. So they had a 100,000 gallon fuel tank, right? They didn't even play. Every year the fuel company came out, they pumped the tank dry, they sent people into the tank, scrubbity-doo-dah, filled it back up. They want to be up. They don't want to go down.
Okay, I got a question.
Yes, sir.
We have y'all as one of our.
Good choice.
Know what I mean? I have never received anything on my, what do you call it, my final paperwork that I get saying that he checked my diesel quality, if it was good or not. He checked the amperage and all that, but he never checked the fuel.
He's never taken a
quality.
sample of the fuel. Is he required to do that?
It's not required.
Okay. But can we request it?
Mm-hmm.
You can request.
That's fine.
Yep.
I just, wish he
That's
goes
good to know. Good to
Yeah.
know that.
Oh, yeah. Yeah. It's a problem. NFPA 110 says test your fuel annually, which is vague, right? It's not telling you what's good, what's bad, what the test should be. I'm on an organization with EGSA. We're trying to put parameters around that now, trying to push that through to say, okay, this is good, this is bad, this is what this is how you should test, this is fail, this is pass. Now, we do live in Texas. This is not an apple core. This is a fuel filter. And that's what happens when it gets cold. It gels. So when you're a Yankee, you need to concern yourself with temperature, right? And Amarillo, all those folks who don't think about it that much, this is what happens to it. So when it gets cold, it waxes, or it congelates like that. If it gets hot, it waxes. So when you have a day tank system I was talking about before, you would pull from the main tank and the generator would pull from the smaller tank. A diesel generator has fuel that runs around it the whole time, right? There's a return line. And that makes it nice, right? It can handle load steps because the fuel's right there. It just has to pull it in from the rail, right? But it exits fuel. So a lot of people with the day tank, they'll get cheap. And they go, well, I'm going to run into the return line. Instead of running all the way back to the main tank, I'm just going to run it here to the day tank. And so what they do is they end up putting hot fuel in the day tank, and now hot fuel's coming to the generator, and then that waxes the fuel. So you get this wax covering on the inside of your cylinders and on your injectors.
Do you cure that with more additives?
No, you tell it to go away. You send it all the way back to the main tank, or if you don't have that option, you do a fuel cooler. You actually run it through a little radiator. So on a sub-base tank, probably not going to run into that issue, but hot fuel is not good. So it always comes down to how much fuel is enough then? I don't want all these problems. I don't want to own all this fuel. That's why people are going natural gas. But how much fuel is the right amount of fuel to have? Now, there's regulations that dictate that, okay? A lot of hospitals are 24 hours. 24, 48 is common. Now, what's funny is every hospital has got to have a 48-hour plan for an outage by law. Every hospital, 48-hour plan. 96-hour plan. 96-hour plan. So their plan may be at hour 30, we leave. That could be their plan, right? So they've got a requirement for local code to run, but they have to have a plan. Now, 96 hours was a number that got thrown around the industry for a while, and people got very confused on this. 96 hours is a number that's been floating around for a long time, and what that number really is when we call for the feds, when we call FEMA, they guarantee they'll have boots on the ground within 96 hours. That's where the 96-hour comes from. So a lot of people misinterpreted that and go, I want 96 hours of fuel. I'm like, oh my God, you so don't want that. You know, you won't go through it. You just won't go through it. So how long, how much, these are big conversations to have. They're big conversations to have. This gives you an idea of how long it takes to run through a tank. So you got 100 kW diesel, 24-hour tank, 30-minute exercises. If you don't do a no-load transfers, it's almost 7 years to go through that fuel when they tell you to do something about it in 18 months. They just don't run. They don't run. And then when you run me without load, I'm like, what are you doing? Okay? This is an example of the day tank that I was referring to. So it's got a double wall here as well. These are all the issues that come along with doing this design. This is a long sit down with the designing engineer to walk this through, to make sure all these things are covered. The other thing, besides them removing the sulfur, engine technology has gotten better. The way you deliver fuel to the block has improved, right? So you're getting better gas mileage. And the reason you want to do that is if you are delivering the fuel properly to your block, you're going to get better emissions. So the idea is you burn everything up so it doesn't go into the atmosphere, right? So old technology of an injector was a nice big fat port here. You could throw a rock through it, right? And it would eat it. Those big 2 megawatts, they'll eat some junk, man. They'll eat some junk because that technology is still like that, right? But what and it's low pressure. When I say low pressure, I'm talking 3,000, 5,000 PSI. So what they've done now is they've changed the injectors to be more of a cone. So what their goal is to mist the diesel fuel when it comes into the cylinder. And that way you get a nice fine burn all the way around it, rather than trying to burn a water full of diesel fuel, right? You've missed it and it burns all the way around. But now this PSI is 30 to 40,000 PSI from 3 to 5. Like, don't be near it. It will cut you in half, right? So because of these openings, they're less tolerant to bad fuel. So now your fuel microns, you went from 10 back in the day to 2. So the fuel goes bad quicker and you need better fuel to operate. It's kind of a double whammy on you. This is fun reading. So this is reference. If you're going to install it, here's all the codes. Here's where they are in the book, so you don't have to hear me go through all this and put you all in the coma. So other fuels, landfill, very tricky with landfill, especially now that we're recycling. Landfill gas consistency jumps all over the place now. It used to be landfills were pretty consistent on what they gave you. Now it's not that way. So you tend to have scrubbers and you have to clean that gas up. You'll know if you did it wrong because in 1 month your engine will be gone. So that's an issue. There's some neat technologies coming out with on-site natural gas storage. So this is being driven by the automotive division. So they're putting carbon and stuff like that into these tanks so you can get more natural gas in a tank. I looked at a system the other day, probably from here to the wall, probably 3 feet round, 4 cylinders, would do 500 kW for 12 hours. So that's pretty cool. So you're storing natural gas on site. There are also big companies now that are doing virtual pipelines. They can actually ship you the natural gas to your site with trucks. The city of Mesa, Arizona is being ran by virtual pipeline. So some different technologies are out there. I mentioned wellhead gas earlier that we're into. So there's some other fuels out there, but it's still consistently natural gas and diesel. That's what you have to think about when you put your gen set inside. And people used to swear that they were so much more reliable indoors. That's just because they saw it. And what they learned is people touched it. That's what they learned. So they keep them outside, put an enclosure around them, and be done with it. So a lot of consideration, indoor applications. So that kind of started going away in the 90s. I miss it. I made a lot of money back then. Starting systems, we talked about earlier with batteries. Here's my thing with batteries, everyone. Don't play. 3 years. 3 years. 3 years. So it's a loaf of bread. It's a loaf of bread. Every time you make a sandwich, you've taken some of the bread away. So there's not a secret baker in the background making you more bread. Every time you hit that battery, you've taken a slice. So if you're at a site that takes a lot of outages, you may want to up your game a little bit. A lot of technology trying to find out predictive stuff on here. It's very, very hard. Doing like impedance testing, things like that, becomes very difficult. But that's a big problem. Big data center guys, they'll do separate battery systems, separate chargers with a big diode coupling in the middle. So best battery wins. 3 years. Please write that down. And we talked a little bit about locations, right? Please don't do that. I went to that site actually. It was there for about 1 day. So it needs room. What you see now, you don't see these on top anymore. Most manufacturers have got away from that. A couple reasons. The main reason is that the exhaust, I don't care what you do to them, they're going to rust. They're going to rust, and then they leak. Then they drip all over your enclosure, and it's there for the next 15 years. And every time I drive by it, I'm like, you know. So they've gotten them off. What they do now is they put them into the air scoop on the end. And that's kind of a neat thing. So what you're doing is you're pushing your air up. So what that does is a couple things. One, it gives you the ability to get that generator closer to a wall. Then it puts your noise up and out, and it hides your exhaust. So that, everyone's kind of has gone to this design. And you can see it sitting on top of its day tank. Exhaust, you got to figure where your exhaust is going to. My favorite story, I was a technician. I did a startup, 4 1 megs at a telephone company, 27-story building. They built a generator plant right next to it. I started everything up, black start, first time, smoke billowing out. That's my favorite part, by the way. Just every bit of it went into the air intake of the building. I don't think one bit of exhaust hit the atmosphere. They ran out of that building like a freaking anthill. I'm just going, wow, that's a problem. So know where your exhaust is. And you can get crazy with it. You just have to tell us. We'll help you with the sizing and elbows and that kind of thing. But know where your exhaust is going. Okay.
We're going to take about a 5-minute break and then we'll come back.